No time like the present. So why don't we go ahead and get started? Welcome everybody. This is our fourth session in our repair seminar series. Today we're going to be covering common soldering techniques, specifically for trombone. Next week, our unofficial last one of these is going to be focused on trumpet. But we're thrilled for you to join us. I've been downloading these and putting them on the website, scshires.com/repair seminar, so you can go back and watch them if you're interested. I am also going to enable them on our YouTube page, so it's a little bit easier for you to get to in case you're interested. Without further ado, I'm going to throw it over to James to introduce our colleagues who are going to be presenting today, talk you through a little bit about what we're going to be covering. And then if you have questions, please feel free, pop them into the chat. We'll take a look and we'll make sure to work them in. But without further ado, James Monahan.
Hi, everybody. I'm James. I'm the general manager here at Shires. With me today, as always, Kenny Pyatt, the head of our repair department. And joining us for the first time here, Nick Martino. Nick is one of our two trombone valve section builders here in the shop. He's been he's a great craftsman. And I'll throw it over to Nick here. Tell us a little bit about yourself.
Yeah, sure. Happy to be here. So I've been with Shires for almost 2 years. There you go. I have been building valve sections the entire time that I've been here. Before that, for about 15 years, I was a repair technician. I started the bulk of that 15 years. I've worked in a rental shop apprentice, and I've started working on rental instruments and school instruments, and then found myself working for a custom brass custom brass shop, which was very exciting, working on higher end instruments and whatnot. And then I found myself with the opportunity to move north. I worked in New York, just outside New York City primarily. And then I found the opportunity to move north and to work for Shires. So that was very exciting. And and here I am. Here I am building valve sections for Shires, and it's been wonderful. So
cool.
Yeah.
All right, Nick. Well, we have a pretty good lineup of stuff today. I think we wanted to talk a little bit about the materials that we use to get started for both building valves and doing the repairs here. So we use a lot of different types of solder and a lot of different types of flux here. So why don't we start to talk a little bit about those materials for the basic building blocks of solder repair on trombones?
Yeah, sure. So I think just to get started, I think terminology is really important too. I found myself as a repairman, trying to parse the different terms that we use for different types of soldering, soft soldering, silver soldering, brazing, and what the differences are between those. Primarily what I've learned, especially since I've started here, the main differences involve temperature for the most part. So when you're talking about brazing and what we would refer to as silver soldering, you're talking about pretty high temps. You're talking about over 1,000 degrees usually. There are some alloys of braze that will liquefy and flow at lower temperatures, but for the most part, it's going to be somewhere in that 1,100, 1,200 degrees Fahrenheit range. Soft soldering, on the other hand, is obviously a much more common repair that we're going to be working with, and we use a couple different types. We generally use 50-50 tin lead solder, and that's going to flow. Most of those alloys will flow around 400 degrees or so. So being aware of what temperatures we're working with are pretty important, I think. We also use a tin silver solder, and that's, I believe, a 96-4 alloy. Yeah. And since it's got more silver, it's got silver in it, it's going to flow and liquefy at a slightly higher temperature. So that will hold a little bit better when we're working and soldering in that area of the horn. So for instance, if you want to go over here, I'll give you an example. This is an a tenor axial valve section. And you'll notice there's certain situations and parts of this instrument, like this front brace over here, where this needs to be soldered, these two sockets, and there's a brace rod in there. And also this ferrule needs to be soldered. So what we tend to do is do the brace first, sockets here, use the tin silver, get that soldered, wiped, cleaned up, and then solder this ferrule right up there with a 50/50. And since it flows at a lower temperature, as long as your heat control is really good, you can solder that ferrule without having to worry about this brace coming loose. Cool. So that's generally why we use the different types of solder that we use. Yeah, it just makes it easier for us generally.
Do they require different flux, the different types of solder?
We use a couple different kinds of fluxes depending on the situation. I find that generally most fluxes will work with either. We use a lot of Johnson's flux, the original Johnson's flux. I've also been using Stay Clean. That's what I've been using primarily lately. It's a little bit more of an aggressive flux. It also turns it gets like a darker color, like a brown, as it gets dirtier, so you can see when the flux is on there. So after you're done actually soldering and you want to remove the flux from the joint, it's easy to remove because you can see where it is. Makes the whole process a little bit easier. Great. So yeah, Stay Clean has been really good so far. So
all right. Do we have any questions on maybe there's a certain type of solder that you guys like to use? Do you have any questions on the type of solder or the flux that we use before we move on to the actual repairs?
I don't see any questions in the chat yet.
All right.
Yeah. Do you Joe asks, do you prefer paste flux or liquid?
So for soft soldering, definitely prefer liquid flux. You can see we have a couple of these bottles. So this is my Stay Clean. I have this is the Johnson's, and I've got a different MA flux over there. So for soft soldering, the liquid seems to be much easier to use and, just tends to be a little bit more thorough. For brazing, definitely the paste flux is easier. We have, again, a couple different kinds of paste flux that we use. But it seems to stay put a little bit better at those higher temps, and you can see it when you're brazing. So, yeah, cool.
All right. Well, why don't we move on to our first repair here? We have a true bore base valve section, and we are going to be doing some repair on the hand slide brace, the hand slide receiver, right, Nick?
That's right. Yeah, cool. Yeah. All right. Yeah. So, before I even get started, this valve section, we're going to work with a couple different valve sections that we built in various stages of completion. So I had some stuff to show you. Cool. So I started building this base true bore valve section. I left this one unsoldered so we could demonstrate it here. That being said, any solder joint that we're working with, I think one of the most important things to remember when doing it is making sure it's clean. Yeah. So we have a ton of different sandpapers, brushes, all sorts of things to make sure that there's no dirt, there's no contaminants that might make soldering more difficult.
Right. We don't usually have our supervisor here. But one of the nice things about working here at Shires is all of our repairs are supervised here by Joe Alessi. All right, so we're getting the thumbs up. Every so often he'll drive all the way up from New York to make sure we're doing it right. So, so hi Joe, thanks for stopping by. Good to see you. Excellent. All right. We got the thumbs up, so I think we're okay to go ahead and proceed with the hand slide receiver repair.
On that note, the cleanliness of the joint is super, super important. We generally deal with different types of things than you will as a repair tech. Most of our, contaminants on the joint will be, draw oil and stuff like that. Although you won't be dealing with that, you'll be dealing with all the other stuff that gets on a horn throughout the life. But I think the point is still pretty much the same, that making sure the joint is clean is super important. So I've already gone ahead and cleaned this, so we don't have to worry about that.
Okay.
Nick, we do have
This,
a question. So Bobby is asking, what would you suggest for soldering lacquered areas? And I think this goes to what you're talking about, prepping and cleaning stuff. Like, obviously, what we make here fresh is never lacquered when we're soldering. But if this were a repair, how would you prep this?
yeah, that's generally something I don't generally have to worry about as much when I'm doing valve sections versus when we're doing repairs. Yeah, so generally solder will not really adhere to a lacquered area. So I mean, it's getting that direct area clean or free of anything is going to be important. The area around that lacquer, there's several different things you can do to protect that area. But that being said, most lacquers burn at about the same temperature that lead solder liquefies. So it's going to be really difficult. I would say that in my experience and our experience here, prep your customers to understand that some of the lacquer is going to burn. It's going to happen. I think next to a neat solder joint, the most important thing is how nice you can clean it up afterwards. So I find that to be true. Yeah, some lacquer is going to burn. We have a couple different things I'll show you that we use to try to prevent other areas. So this is a gel that we will spray on a lacquered instrument if we're doing a repair to the area around the joint that we're lacquering. And I'll just show you. It kind of comes out in that sort of consistency. It sticks to a tube or a joint pretty well, or an area pretty well. So generally don't have to worry about it falling off, but it will generally prevent.
So that works by drawing some of the heat away or cooling down the area that you're soldering. Is that right?
Yeah, that's exactly right. There are some other things that you can find in like a general supermarket. Pledge works surprisingly well. Sure. I've had experience doing that. Although when you start to heat it, it feels like you're frying like chicken. It like sparks. So be prepared for that. Wear your safety glasses for that.
I know when I was repairing, to keep solder away from spots that you didn't always want it to get into, we'd use a grease pen.
Yes.
Do you advise using that? And in what way would you use maybe a grease pen to protect some areas?
Yeah, you can do it. I mean, really, it's going to be anything that draws the heat off of the area that's lacquered that you want to protect. So yeah, that'll work as long as you don't get anything where you're actually intending on flowing the solder. Then you're pretty much be in good shape. I even used a wet rag. We would rip the rag into strips and soak them, and then wrap them around the areas to prevent the burning. So that was fairly effective in some circumstances. But
yeah, for any we all have found that with any lacquered instrument, burning lacquer unfortunately is inevitable. And for a lot of the customer instruments that come in here, where we just have to do a solder repair somewhere where it's lacquered, what we'll do is we'll take some buffing compound and we'll rag it so at least the burnt lacquer is cleaned up, and so get that looking as clean as possible. At times, if it really needs to be protected, we might do some spray lacquer like in the can that you can find, but the spot lacquer. But by and large, lacquer will burn. Lacquer burns away a lot faster than the solder will. So.
Yeah, and I think lacquer for the most part is meant to be a temporary protective for your instrument. So if it happens, it happens. I usually try to prepare my customers for the idea that some of that will be will be burnt. So yeah. Cool. Yeah, I can go over after we solder some of this. I can go over quickly about some of the techniques I use for cleanup too, if that's helpful. So
Nick,
yeah. So,
Nick, one question.
Yeah, sure.
What's the brand of that protective gel?
Yeah.
So it's called Kimball Midwest makes it, and the type is Therma Shield Heat Protection Gel.
You can also get the Cold Shield from Allied, which is very similar.
So our other builder here says Cold Shield Protective Gel from Allied is also good. Is that right? Yep.
Yeah, there's various things that you can buy by a lot of the repair suppliers that will help tape different tapes and different products. And most of them are fairly effective, but like I said, it's going to burn. So
It'll burn.
it'll burn. It's fire. So okay, cool. So I'm going to go ahead and solder this this guy. For this joint, we're going to use a 50/50. I'm going to use a Stay Clean Flux. Use acetylene torches. Find that they're pretty good. They have a nice controlled torch tip that you can see pretty clearly. I'm going to heat it up a little bit first, just to kind of get when I add the flux, to get it to flow a little bit into the joint that we're soldering. I'm pretty carefully applying it, trying not to let too much of that boil off. But I also know that if I add too much and the flux starts to drip down the receiver, that's also where the solder is going to go. So we really want to try to avoid that. The other thing is heat control, right? So controlling where your heat goes is pretty important. So this is a big hunk of nickel right here. Generally takes a little bit longer to heat up than that little brass tube that's right above it. So I'm going to concentrate most of my heat right around that area. Get a little bit of solder there, blow it around.
So yeah, that's a good point, Nick. I see you're not trying to heat the brass and the solder directly. You're on the denser nickel and the denser part, the thicker part. So the part that he's heating up is actually pulling the heat a little bit away from the thinner parts of the valve section. That helps with heat control.
Yep. And when you're soldering a lacquered instrument, it will also help to prevent some of the other lacquered spots from burning. So going back to what we were just speaking of.
I'm going to wipe the lens real quick, so I'm sorry if this makes anybody seasick. All right, and we're back. Thank you.
So one of the other quick things while we're just waiting for this to cool down is when we're building the valve sections, we do build them on these fixtures that we have built here in our machine shop. One of the biggest things, and if whenever we get the tours lately, they've been virtual tours, obviously. One of the things we really concentrate on is not spraying down our instruments directly after we solder them. It kind of has to do with a lot of thermal expansion and contraction that happens when you're heating a piece of metal that much. It will expand quite significantly for our measurements anyway, and then contract as it's cooling. We find it's way easier to not spray it, to let it cool as naturally as possible before removing the flux from the joint. And we do want to remove the flux because our next step is going to be to wipe any excess solder that might be on there and clean up that joint a little bit.
All of our trombones and trumpets are made with as little tension as we possibly can get out of them. That's what we believe is part of what makes a horn more resonant. As if there's no tension, there's no parts that are fit so tightly together. We don't use jigs, we don't use clamps. Everything is either very, very, very lightly pressed together with some wire clips that we use, or we use these fixtures here, which aligns the instrument perfectly.
Yeah.
So yeah, just to point out again, we're taking several seconds in between applying the heat here, just to make sure that there's no tension in the solder joint itself.
Yeah, and a lot of the cases, if you get an instrument like this into your shop, you'll be working on it on the bell. So it'll be slightly different, but the concept is all going to be the same for the most part. You would just mount the bell on whatever it might be. We use these to kind of just set the spacing so that the hand slide, once it's screwed in here, is not going to come that close or hit the bell or come too close to the bell. So that's also something to consider when you're doing this type of repair. So, I'm going to spray it off now. So actually, before I do that, if you want to take a look right here, get close in here, you can see some of the discoloration that happened because of the flux that is on there. Which again, I really like because it makes it much clearer to me when there is flux on there. So it's just water, but any kind of solvent will work to clean out flux perfectly non-flammable. We're cleaning the flux off this way. As we start to wipe it, the solder is not going to go all over the place and get everywhere. We use a bunch of different things to wipe excess solder. We just use regular old rags. We also use some Q-tips, some pipe cleaners of a couple different thicknesses, and whatever the situation sort of dictates is what we will do. So I'm going to go ahead and wipe it. In this case, I'm kind of applying the heat a little bit more directly to the area so I can get that solder to the state that it will wipe away at. When you're buying different solders, most of the suppliers, if you go to their website when you buy it, you can actually see what temperature the solder liquefies versus what temperature it flows at. We're looking for that like base liquid state, which is usually slightly cooler than the actual liquefaction, than the flow rate or the flow temp. This way we can kind of get it to that state where it's wipe-awayable. That's a word. A term.
It is now.
It is now. I just made it up. Versus where it's going to flow and just move all over the place. We don't want that. Because I'm fairly satisfied with this solder joint.
Yeah, so I'm going to try and get in and see if I can get the camera to focus so you can see.
I will stop
you
moving.
guys at home can see. That is pretty gosh darn clean. And for all of our joints, trumpets and trombones, we try to get that solder to be that perfect little parabolic curve from the tube to the ferrule itself. So.
Yeah, we do very little scraping, if any.
Yeah, I don't think we scrape at all on the valve sections, especially.
No, I tend not to unless there's a chunk that I can't really get away. In some cases, if your heat control is not great, and you get the joint too hot or the area too hot, solder will crystallize at some point, and that can be a bit of a nightmare. So it's pretty important to keep that temperature as controlled and as consistently at that liquefaction or that liquid state, and not any higher than that, so you don't run into the problem with it liquefying, than having to scrape or sand or anything off. But, cool. I can clean this up real quick so we can show. Generally, change the angle of this. Generally, I use a piece of flannel with a little chunk of tripoli.
Tripoli or buffing compound.
Buffing compound, yep. Yeah, tripoli buffing compound, or rouge, depending on what state of the the repair is. If it's a lacquered instrument, I'll generally use a little bit more rouge. It seems to be a little bit less aggressive, so you can see that. I'll throw that on here.
Voila.
Voila.
There it is, folks. Holy smokes. All right.
Yeah. Yeah, so that's the general gist of that. Yeah, generally that rouge tripoli works really well. Like I said, if it's a lacquered area, rouge is good to sort of prevent ragging away any excess lacquer. So cool.
Great. Yeah. Do we have any questions on the hand slide receiver solder before we move on to our next thing?
No questions yet. Joe said it was a beautiful joint. I can. Good job, Nick.
Thanks.
All right. Thanks. Next up, what do we have?
All right. So we're going to go back to this tenor axial.
Okay.
And I'm going to talk a little bit about, really quickly, the different solders. I'm going to show you because typically, like I said before, the joints, we would use tin silver on areas like this. And good, yeah, that's fine. And also this neck plate brace that we built right here. Another instance where there's a lot of other soldered areas around that. And so this way, we normally solder this neck pipe joint first, neck pipe brace first with tin silver, and then solder these with 50/50. I'm going to solder this with tin silver just so you can get an idea of how it's slightly different. It reacts slightly different heat. It's a slightly higher temperature to flow. It can be a little tricky to work with if you're not used to it. And going back and forth, a little bit of a challenge, but for the most part, let's put that here. So again, I'm going to heat the area right around the brace. Pretty deliberately, add the flux where I want it to go. Now, because the neck pipe brace is soldered at the other end, I'm not going to concentrate too much heat up in that area. I'm going to try to keep my heat pretty concentrated right on the bottom corner of it. So it's a slightly different scenario than what we were dealing with before. I guess there's a little bit of a gap right there. I'm going to add a little bit. And I'm going to flip it around. Can you see it there?
Yes.
I'm just going to heat it and try to pull the solder where there you go. Exactly what I was looking for.
So if you couldn't see that on camera, the solder exploded. Why did that happen? Why did that happen?
Well, so it was when I had it upside down, the gravity of the outer was pulling it down. So there's a slight gap right there. As I flipped it around in order to set the outer where I wanted it to be, I'm going to use the outer slide's own gravity to pull it down onto the brace, which is, we know the brace is set where it should be. So most cases, any of you working on a valve section or a joint like this, I wouldn't recommend using the tin silver in this situation, because you have so many other joints that are around there. It's going to be pretty difficult to get it without everything else kind of liquefying and bubbling out and creating gaps in the other joints to solder. I did want to use this on this one so I could show you guys what working with the tin silver is like. Definitely far from impossible. I really like using it. I think it's, but it's a little bit more of a challenge if you're not used to it. So probably a good few minutes to let that cool down.
Yeah, yeah, absolutely.
So again, we're going to go ahead and spray the. In this case, I'm just going to use a pipe cleaner. I curve it so I can kind of grab some of the solder as we're going. Let's see if I can get the under. Yeah, let me know if you're fine. Okay. There we go. Again, we're looking for that that state of the solder where, I know I'm on the other side where you can't see it, but
Let's see if I can swing around here.
yeah. We're looking for that state of solder that's not quite flowing, but just liquid enough to wipe away. Sort of in between the state. That side. We're just going to move this over here. Probably should have mentioned this when I was doing the receiver. And I had that valve section tilted upwards. Gravity is your friend. Use it. If you can use gravity to move solder, it is really effective. In this case, I'm going to add just a tiny bit more. See slow it down or roll it around a little bit. For instances where solder pops out like that, it's always good to remember to wear your safety glasses.
I'm going to jump in here and describe one thing that you're doing really well, Nick. You'll notice when he was soldering the hand side receiver earlier and also the brace, Nick is essentially just adding solder basically in just one location and then using heat to actually pull the solder around the joint or through the brace. It's really important to try to not solder all the way around these joints because you'll end up with voids in the middle of the part. Solder is going to follow one of three things basically. It's going to go where gravity's pulling it. It's going to go where it's going to be drawn towards heat, and it's going to go towards the things that are the cleanest. And if you can control all three of those elements, the cleanliness of it, the heat application, and gravity, then your soldering will be much easier. If you have any of those things fighting against you, then it makes the job much more difficult.
Yeah, absolutely. And I think that one of the things that I've learned over the years that I've been soldering things, the cleaner, the simpler it is, the easier it is. And that always translates to how neat it ends up. The less you have to clean up, the neater the instrument's going to end up. So, for a minute. And we'll just use a little tripoli right here, sort of polish up that a little bit.
Nick, I know you did several years of customer repairs in a repair shop in New York. Coming here, how would you say that your soldering technique is different for building a fresh instrument versus what you need to pay attention to as a repair person?
I think I became much more aware of how I'm actually soldering as when I started here. Obviously, everybody wants to do the neatest solder job that they can do. It looks better. It's more professional. I think when I started here, really picking apart how I soldered, where like as James said before, the entry point of the solder, keeping that in one spot so it's less to clean up in the end. It makes me happy. It makes our buffers happy. But yeah, really thinking more about the methodology that I was using for what seemingly is a fairly simple job. I'd say that changed quite a bit. It became less of a get it done, get it together, and more of a sort of a much more refined sort of job that I could try to do as neatly as I possibly could. So,
sure.
And as thoroughly. A good, a spread out solder joint is obviously going to be much stronger than one that you have gaps all over the place. So, yeah.
Let's take a look at our finished brace.
Yeah, so you can see if I can get a little.
And there it is, focused. Bam. Nailed it.
So that's the tin silver. Like I said, it can be a little bit more difficult sometimes to work with, but it generally will have a pretty strong hold, and you can solder other stuff around there. So, cool.
Would you use the tin silver on, say, a silver-plated instrument? Is that an okay thing to do?
Yeah. So I originally I discovered the tin silver as a, I think it was the slightly different alloy of that. It was the 94.6, I believe, as like the low temp silver solder patch. And that's how I originally discoveed it. And I used it on quite a bit of instruments that were either cracked or had a little a pinhole or something like that. That you can use to patch it up, and it's pretty strong, so it will stay there. I would say that if you're soldering a silver-plated instrument, the thing that you're going to want to be most careful about is not burning the least amount of plate on it. So again, heat control is going to be really important, but yeah, it blends really nicely with silver plate. I find that it will hide the marks of your soldering pretty well. So I guess that's sort of the name of the game when we're soldering, right? Try to pretend like no one was here doing anything.
Exactly. All right. Do you have anything more that you want to add on the neck pipe brace here, Nick, before we pop on to the next thing?
I don't think so. I think that's pretty much does it on that guy.
Do we have any questions about that? No?
Just to reiterate on that, I'd say that I did this with tin silver. We do that here in the shop. If you're able to clean it, and when you're repairing it in your shop, especially if you're doing the other joint down here, you may not be able to. You may have to use a lower, like a 50-50 or 70-30 or 60-40, whatever you're using, to do it without making the other joints explode out. So, cool.
All right. Next up, I think we have the dreaded tuning slide leg repair.
So this one is actually a tuning slide leg that was taken out. So we can kind of go through and just do that. Like, I'm going to just do a quick cleanup on this. So I'm going to use a little Scotch-Brite. On this, it's great because it's not lacquered. So we can pretty much do whatever we need to do to clean up the joint right here.
I'll just reorient myself here, try to deal with all the wires. Okay, and we're back. So this is especially notorious. I remember when I first started out as a young, inexperienced, terrible repair tech, I wouldn't be able to get the ferrule clean enough. So I see that you were using some Scotch-Brite on the leg itself.
Yeah, so there was a lot of excess solder from when it was actually soldered, which I just used some Scotch-Brite to clean up. Maybe a little sandpaper or something that will make sure that your joint is as clean as possible again. Just to scrape that off. I used this red Scotch-Brite, this gray stuff seems to do just about everything I need. So the gray is slightly less coarse. Just to clean it up and make sure it's all. I mean, there are times where if I'm worried about oils or anything like that, or any other excess dirt, you can take a little alcohol and clean it off with that. Just make sure, obviously, that the alcohol evaporates off before you try to solder anything.
Otherwise,
So with the inside of this ferrule, it came out pretty cleanly. So there's not a ton of solder in here, but I will show you just what we use as far as we've got a number of these wire brushes of different sizes. And we'll just kind of put those in a drill. That's clean that up a little bit. Q-tip with a little alcohol. I hope this narration is helpful as I do it.
I'm loving it.
Okay. So that's pretty clean.
So you're scoring the surface of the leg, you're scoring the surface of the inside of the ferrule. That helps get all of the oil, all of the dirt, all of the particulate out. I've also found that adding a little bit of texture to the surface that you're soldering will help to bind the solder to the surfaces that need to be bound.
Yeah, it gives you something to grab onto.
Yeah.
Sure. Yeah, for sure. If you're ever working on our F slides, you may notice that the stamp the bottom serial number. Is it maybe a little bit? So we'll do the last
Trust
three.
us, there's a stamp there.
Yeah, trust us that it's there. We generally try to keep that on the outside of the slide so you can identify what slide it is. It's mostly for job purposes, but it's a fun little thing. And then we're going to do this in the instrument. And normally, when we build these, this might be fun to see. We build them on another fixture. Again, another fixture that is made in our machine shop, and it's done with a large amount of precision to make sure that the slides are parallel. So we will build these first, and then build the valve section with the F slide in it. So that pretty much ensures that the outer slides are as parallel as possible. Usually pretty spot on. So.
Playground Music just asked where we got the dispenser bottles. I just threw a link, an Amazon link up in the chat. There's a variety of these. There's a 4-pack here for $10, 1-day shipping on Amazon Prime. If you kind of just search for a solvent dispenser bottle or a push top dispenser, there's a variety of these available. They're really handy.
Yeah. Very popular too. I'm just putting it on some slide reel on there to make sure that it moves. The nice thing about having some slide reel on that too, on the inner, is that the slide will not flow into slide gel. Some excess here. So if I do get slightly sloppy or lazy pouring solder around there, I generally will not have to worry about it soldering the slide in, since there's plenty of slide gel on there. I'm going to bring it in as close as possible because I wanted to make sure that the inners are as parallel as these outers are.
Yeah, I was just about to ask, Nick, how far and why do you want to push in the tuning slide?
Yeah, I'm going to push it in about there. Like I said, we know that these are pretty parallel because they were built with the slide in it. And the slide was built on the fixture, which we know is parallel. So yeah, I'll go in as far as definitely more than halfway. As far as I can tell that the slides are angling correctly. They're not angling out of parallel. So that's obviously going to be pretty important for the player as they move their slide in and out. So do that. So having a non-lacquered surface here is going to be fantastic because I don't have to worry about burning this area. If you're working in your repair shop and this is lacquered, again, you can use the gel, you can use any of those numerous the several techniques that we talked about as far as saving lacquered. This is really close, and we're going to be soldering this really close to here. There's a very good chance that this might, bubble up. Soldering over here might spill out a little bit. I'm going to do my best to not let that happen, but it does happen, and we just clean it up as it goes. So let's see what we got. So again, same technique. I'm just going to heat a little bit there. Make sure I got Flux where I want it. I'm going to go back to my 50-50 here. Yep. We got a little bit of solder leak out right up here, so I'm going to take care of that after we get this one done. So. Again, in an area where I don't have to worry as much about I don't have to worry as much about the sanding on here because, again, we can just clean it right up, and it's a non-lacquered area, so it's not going to be that big of a deal to either use a little,
see if I can
triple E or anything like that.
get this to focus. Might take a second. Doesn't like it, but
No, doesn't like it. Yeah. If you can see.
Yeah.
What will happen sometimes, so you see right here, the heat over here pulled this down a little bit. So we got a little bit of a gap right there on the top end of the ferrule. So I'm just going to put a dab of flux on there, blow a tiny little bit of solder on there, and fill that little gap. There we go. We'll let it cool down for a minute.
so you can see there is a couple little dots of the solder there. We're going to take care of that with wiping right now.
Yeah, we're going to take care of that with wiping. I'll use a Q-tips, Q-tip on this one usually, or rag.
Great.
See how I feel.
It's Wednesday, so anything goes.
It's true. Dealer's choice. Yeah, again, just waiting a few, a minute or two, just for that joint to cool down as naturally as possible.
If you were to spray the joint with water immediately, what would that cause to happen?
Yeah, so that contraction will happen pretty rapidly. And what it can do is it can change the set at which the inner and the outer meet and the ferrule are meeting. So you can change the parallel that you end up getting. It's mostly evident if you ever have to resolder one of these brace rods and sockets. That is always a really apparent if you spray it off really quickly. They pull in like a lot.
Yeah.
And we build them with a tiny little space over here so that there's enough room for the slide to be parallel either one way or the other.
Yep.
So you can always feel when the socket pulls in.
Yep.
When you spray it down rapidly, and that will cause the slide to go out parallel.
Yeah, and we'll talk about this a little bit next week too with the trumpet repairs. When I was building tuning sites for trumpets, especially, we have a fixture for that too to keep it very, very parallel. If I were to spray it off too quickly, as soon as I pull the tuning slide out of the fixture, tink, it's not even close. So take some time to let the solder cool down so that it stays exactly where you want it to stay.
Yeah, all these other joints around here. I need to keep it so I can be a little bit more exact. If we keep it a little more deliberate. I got a little bit of a chunk left over from my entry point right there. I'm just going to keep that up and kind of wipe that guy away. Yeah, understanding the as we said before, the different states of solder at the temperature that it changes is always something that I thought a lot less about until I started here. Getting that solder to that sort of like muddy state is how I think of it. It's really what we want to be. So it's going to take not a ton of heat to get it to that point. So.
So we've got a question about ventilation and dealing with soldering fumes.
Yeah. We have a great ventilation system in the room that we are working in. Oh, you're fine. You're fine. So as you look up, there's a couple vents right above our heads that will sort of bring the fumes away from us.
We have them all throughout the room,
Yeah,
and
all
here I'm going to try and give you an aerial view. So we're fortunate to, when we moved into the new building, we're able to make sure that the ventilation was good, as well as some very clever engineering by the guys who work here to make sure that the soldering area, the brazing area, and especially the buffing area had more than adequate ventilation.
Yeah, and not to sort of tiptoe around that talk about, there's a lot of talk about lead solder and how we work with lead. I know a lot of guys in our industry have had problems with lead solder, and but we found a really good way to work with it, obviously using gloves. And for the most part, unless you're doing a ton of ragging or buffing afterwards, which you honestly should be wearing a mask when you do it anyway, we find that that's the safest way to do it without breathing in or sort of getting any of that, that lead inside, getting in your mouth or in your eyes or breathing it in. It's going to be fairly, safe to work with on this.
We frequently get our areas tested for lead. We have special lead wipes called Lead Off, and we can show you that little can here. They're wet wipes. They're called Lead Off from Hygenol. They do a pretty good job of wiping away all the heavy metals from the surfaces here. The contamination, and pardon me if I'm speaking out of turn, James, I think a lot of the contamination comes from surfaces.
Yeah, I think that's accurate. Yeah, there are going to be some fumes, but proper ventilation. If anything, just if you're working in a shop that doesn't have all the resources we do, just expelling the air out of the room, some sort of vent hood or open a window, putting up fans, that will do a lot.
Yeah, I really, the only tech that I know that actually had lead poisoning from on the job, he was in New York City, worked in a closet of a repair shop, and was constant, which was very poorly ventilated. It was constantly there was a lot of room to move. There was nowhere to eat, so eating and putting things, and breathing things in that tiny little unventilated space was pretty hazardous. But I think as long as you're ventilated, you're ventilated. As long as your room is vented and the area is clean, I think you'll generally be in pretty good shape.
Yeah.
Nick, we've got a question about the gloves you're wearing.
Oh, sure. Yeah, these are gloves became hard to get about a year ago.
Very difficult.
Yeah, very difficult. So, but we've landed on these guys. They're fairly comfortable. They fit pretty well. They fit nice and tight.
Yep. I think the material, it's a black nitrile. We like the 4 mil thickness gloves. If you get much thinner than that, they start ripping and tearing. If they're much heavier than that, you lose feeling in your hands. Yeah, you feel like you're wearing cotton gloves if they're heavier than that. So yeah, they're pretty nice to work with, and they're comfortable. So yeah. There's a variety of brands on Amazon. We used to buy these on Amazon before the world started hoarding nitrile gloves. But yeah, if you can find them, suck them up. Yeah, cool. So that's what you got after being cleaned up a little bit.
Let's see if we can get one more close up on
Yeah,
that,
will it
that
focus at all?
seam there. It takes a second sometimes.
Nick, we've got another question. Do you have any tips on soldering things like bows or hand slide tubes or tenons where you need to pull solder evenly across a large surface?
Yeah. Well, for something like a base axial Bollinger model that we build here, there's a really large, one of the slides is made with a very large sort of socket where solder has to be pulled way down into it. Evenly heating is going to be the best advice that I can give you. So again, I keep saying it, but it really is, it's true that it's one of the most important things about soldering is heat control. So making sure where you want the solder to go is hot to the temperature that you want it to be, and then making sure that your solder, liquefies that and flows in that direction. So, it's just control of flux, control of heat, and you should be able to get it down there. And again, like we said before, gravity. So I will tend to angle a valve section or a slide or anything else I'm working on so that gravity will help me pull the solder in that direction. So when I'm doing those sockets, I will put them up on the bench and just kind of heat them to pull the solder and flow it downward.
Great.
I hope that answered the question.
I think it does. And I can speak to this, myself doing things as large as like the bow guard on the bottom of a euphonium, or really large plate kind of things. The same techniques hold. You want to make sure the parts are super clean, they fit together properly, there's not big gaps or kind of like voids that you have to fill with solder, and just really careful, methodical heat control and pulling the solder across the joints, as opposed to trying to feed solder all the way around a joint.
I think of it a lot like painting. I think that half the work is done on the prep. So if your joint is prepped correctly, then you're halfway there. Then it's just actually, again, doing all those things that I talked about, heat control and stuff like that. Prep work is essential, and it's essential to have it just the way you want it before you start taking any solder or heat to it. So.
Okay. Last question. Any thoughts on soldering hand slide inner tubes into cork barrels?
Into cork barrels, yeah. So I do this more since I don't build hand slides here. I just do valve sections mostly. I always had a lot of success with the cork barrel of having the inner tube sort of sticking out of the cork barrel a bit, and then sort of almost sort of like tinning the area that you wanted the solder to go, and then pulling it up, and you're able to wipe the top of the joint, to clean it up. And this way, that you're getting solder everywhere that it should be, and nowhere that it shouldn't be.
Yeah, right.
Like up in the cork. So how many times have you gone to take out a felt or a bumper from a hand slide, and you can feel that notch of solder, while you're trying to take out the felt or the bumper, like grabbing your tool. I think solder is really it's not a filler, right? We really don't want to fill so much as we want it to just bond two pieces of metal together. So not overusing the solder that you're working with is really important, I think, in a scenario, especially like that.
Great. Yeah, we're right about the 1 hour mark. If there are any other questions, drop them in the chat. I think you did a great job both demonstrating the soldering techniques and describing everything. So thank you very much.
Yeah, no, thank you. I hope it was informative in some way.
Yeah. Got a question from Joe. What thickness solder are we using?
Oh, so this I go through two. Let's move that a little bit. I believe the thicker is the 062. 062 and 032, I believe, is the thinner, the diameter of the thinner one. Mm-hmm. 031, 032, something like that. I obviously, it's just depending on what area. So when you have a pretty open area like a tuning slide or an F slide inner, or a ferrule where there's nothing sort of in your way to do the work. I find a larger diameter kind of gets a little bit more solder quicker. And then the smaller one for when you have sort of precarious areas or you have a lot of room to get solder staining around there. It's also really good for entry points on lacquered instruments. The thinner stuff, it leaves less of a mark. So if you are working on an instrument that's lacquered, it's good to consider.
Cool.
Yeah,
All right.
great.
Well,
I think that's all we've got for you here.
Looks like we've got Sam back.
I just want to say thank you, and Joe's over there. Say hi, Joe. Just thanks everybody for joining us today. This is so fascinating for us to watch on the daily, and to be able to present it to all of you is really special. We have another session next week, and that's going to be focused on trumpet solder. If you have other questions, always send us an email, repair@seshires.com. And this video, like the others, will be uploaded to seshires.com/repair seminar. And I'm also going to enable the videos on YouTube as well, so you can take a look at them there. But I just wanted to say thank you, since I had to jet for a few minutes. So cool.
Yeah.
All right.
Thanks, everybody.
Thank you, everybody.
Okay, we'll see you all soon.
Take care.
Bye.